Hello. Okay. So we are live. And we'll solve the remaining problems starting from this sushi problem. Okay. Let me go to the whiteboard and see if we still have access to that board. No, don't have. Okay. So before that, let me make a new file. Let me make a new file. Not this. Okay. There are n dishes numbered 1 to n initially for each I, which is 1 to n. Dish I has AI pieces of sushi on it. Taro will perform the following operation repeatedly until all the pieces of sushi are eaten. Roll a die that shows the number 1 to n with equal probabilities and I be the outcome. And let I be the outcome. If there are some pieces of sushi on dish I, eat one of them. If there is none, do nothing. Find the expected number of times the operation is performed before all the pieces of sushi are eaten. Expected. Expected, yes, I need this. So it will be I times 1 by n. So I by n, summation of I by n. That will be the what? That will be the expected for x, and we need to do a summation. This is the expected value. So here expected number of times the operation is performed before all the pieces of sushi are eaten. Number of times the operation is performed. Before the all the pieces of sushi are eaten. pieces of sushi are eaten before. Okay. Number of times the operation is performed before all the pieces of sushi are eaten. We sushi can be from 1 to 3. Okay. I can't think of how to approach this problem. I'm not even sure what the answer is supposed to be. Let's look at some test cases. Okay, so how is he getting this? It's the first sushi we eat. What is the expected number of operations before the first sushi is eaten is 1. We have this. Okay. So when we take the first when we take the first so when we take the first sushi, when I eat the first sushi, the expected number of operation before that is 1. Okay, so here our random variable will be number of experiments, number of operations. Okay, one. We'll solve the next problem. Case tools. Okay. We'll solve the K stones problem. Okay, try to solve it. We are given n, k, and then a1, a2, a3 up to an numbers. What these numbers are? They are basically this set. This is basically this set. Okay, that contains the moves that the players can perform. Taro or what? Zero. Okay, so the first player is Taro. Second player is 0. Okay, first is Taro, second is 0. So we will be given k stones, and our task will be to make other player unable to make a move, and in that case we will win. Okay, so for example, here in this test case, copy it, paste it. So here in this test case we have 2, 7, 2, 3. So we have 7 stones and 2 and 3 as the move options. Okay, so Taro can choose to make a move. Either he will take 2 out or 3 out. Okay, and if he takes 2 out, then he will be then it will be 5 and it will be 4. Now this 0 is moved. The 0 stand. 0 can do 2 or 3. Similarly here also he can do 2 or 3. Okay, and with that he will end up with this. Okay, so we need to remove exactly that much quantity. This whole path is not optimal, so they are not going to play this move at all. Okay, this whole path. So they will most likely try to play this or this. So in all cases Taro wins. Okay, oh sorry, in all cases we have first move and then we have second move. In all cases, not in all cases, you see, if he takes 2 coins, if Taro removes for 2 stones, then only he can go to victory. Otherwise, if he takes 3 stones, then there's a chance of him losing. So he will try to take 2 stones in first, and then leaving 0 with the option of again 2 and 3, which is then easily removable by Taro. So the winner will be Taro. So I think it is very apparent that how the algorithm is going to be. Okay, so for a number we'll try all the possibilities, right? Suppose we have a number, let's say 7 or let's say 9. We have a number 9 n. Okay, and we have a list of possible stone removal, and we would like to do it from that, remove it from that. So there can be n different ways of removing it. Okay, minus a1, a2, and an. So we'll do all this, and whatever we end up with, we'll do again the same thing. So it is kind of like a DP where multiple where DP states are going to overlap. We cannot draw all of it, but it is going to overlap. Okay, so yeah, for example here in this case, from 2 we only have option of 2 and 3. Here also we have 2 and 3. Okay, so we have overlapping sub problems. Okay, so yeah, so our DP state will be DP of I will be what? Should we make a boolean type of thing where 0 will represent that first player has won and 1 will represent the second player has won? Okay. Or maybe true or false. Okay, so DP will represent whether whether Taro will win or not if there are I stones. Okay, something like this. Something like this. Okay, and our transition will be, this is our state and our transition should look something like this. dp of I is equal to uh, dp of I or dp of j for all j belongs to A such that, no, how did we do such that expression in discrete mathematics. Okay, I was right. Such that our j is less than or equal to I. Okay, and if it is 0, then Taro will lose, obviously, so it will be false. Base case will be that. Base case is what? dp of I is false for every I is equal to, not for every, dpi is false for I is equal to 0. False for all I less than equal to k. Okay, and another base case is dp of I is equal to no, what am I doing? This is not the correct. K is number of stones, right? So okay, so if we have more okay, so if we have less stones, then in that case it will be false. So here for all I greater than equal to k, it will be false. And where else? It should also be false where suppose Taro made a move, and he made a move such that he made a move such that he made a move such that we don't have any move set, we don't have enough stones to remove, right? So yeah, that is okay, so it is this one only. So when it will be true, so it will be true when, so Tara will win when he made a move and there are not enough pieces left. stones left. There are not enough stones left. For example, all the k equal to multiple of odd multiple of okay, so he will win for all those cases where I belongs to k, I belongs to or k belongs to a. He will win in all those cases, and all the other we will just we will make answers from the previous state. So I think this should be fine. Answer will be dp of k only, right? Okay, so we have the solution. Let's implement it. So okay, I'm setting the base case as true, and then everything else is already false, so there is no need. Okay, so now we'll run the loop. So we need to do it for all the number of stones which is from 1 to 10 to the power 5. Okay, and for all those stones we will check whether it is possible for Taro to win. Okay. One thing I want to do is I'll just sort the options from the set, and I'll go from this, and also we'll check whether pi is less than or equal to number of stones. Okay. This will help us reducing states in reducing states. And we'll do dp of I and dp of I minus j. Okay, dp of 0 is also false. And at the end we'll just check if dp k, then we'll just see out first, else second. C. This is the OR option, right? Okay, we are back. Segmentation fault, most probably coming from here. Okay, and so it is coming from here. Where is it coming from? This line? Okay. Maybe from here. We don't need to go N, we'll go to K. Second guy is winning. How? Okay. there is a logic flaw in this solution. Basically, we are not accounting for the second player at all. We need to have one more state. Then how will states be dependent on each other? Okay, so it is something like this. No, not entirely, but kind of. Okay, so I think we'll need a player state as well. So our new DP state will be I J. Where it will show whether player J won out of I stones. Okay, in that case our transition will be dpi. I'm giving it 0. It will be, I want the first player to win. Okay, I want the first player to win. For that, need to check for all the cases where the second player lost. So dpi second player lost, or dpi 0. It's the very same that coin question, bro. It's that very same coin question. We were so close. And also one thing that I would like to do is, why the fuck I just did this? Okay, at least something changed. What is the logic of this dp I minus mo double equal to 0? That means the last person should not have any move. Okay, should not have any remaining move. Okay, so okay, so we don't need to do all this. Okay, so this thing here, uh, this thing is okay. I don't need this. This is not okay. It should be 1 for all j belongs to a, such that j less than equal to I, and dp of j and dp of j minus dp of I minus j is equal to 0. It means that if I take this number, then the other player will be other level will have the choice of this only, right? If I take j stones, then other player will be having I minus j stones, and I don't want him to win in that situation, so it will be 0. So it will be dp, oh sorry, it is 0, and yeah, I was so close again. Paste it here. Oh sorry, I paste it here. Okay, so yeah, this is that. Okay. So this is the answer. I don't need this. Let us check all the test cases. Should be second. First. Okay. Second. Okay. Something happened. What happened? Okay. One thing. This should not be I. Should be J. So it is second. And we have one more. Here it is second. We have one more. Here it is first. Okay, copy and paste, submit. Okay, so actually I'm feeling very sleepy. I don't know why. Wrong answer. TLE MLE, please. No. Thank you, whoever it is, for reminding me of my past mistakes. No bhuyar. Okay, I did the same mistake again. This question is not done. J Sushi. We'll see how to do it. Expected number, I'm having a lot of doubt. And DQ. Taro and Jiro will play the following game against each other. Initially, they are given a sequence until A becomes empty. The two. Okay. Remove the element. Okay. Okay. So we already solved it. Okay. So we'll just do it again. We are at L DQ. Okay, and again we have an array. Okay, for example, this. We have an array. Which is this. So player 1 can choose either this one or this one, and after that he will include it in its score, either 10 or 30, after which the other user can choose, and they are going to do it in a way that will maximize their scores. Okay, so one thing that we can see is that when a player takes one element either from this side or this side, they are adding that score to their total score. Okay, so let's say it is xi that the player has chosen and player 1 has chosen, and it is yi that a player 2 has chosen, and it is all going to be added in this x y or x, right? So see, if we are choosing numbers such that, so if we choose this number, what do we want to do? We want to maximize our score, right? Okay, also we want to maximize our score, but also we want the opponent's score to be minimized. So what we are doing essentially is we are trying to do we are trying to maximize x minus y. Okay, so we are trying to maximize x minus y, but player 2 wants to minimize x minus y. Okay, player 2 wants to minimize x minus y. So instead of absolute score, we are going to be working with difference in the score. Okay, and at the end, since we have the total score x plus y, we will calculate the basically individual score for each player. We can calculate that. So if we can get the maximum difference in their score, then we can get the final score of each individual player at the end. Okay, so how are we going to do it? So the state I am thinking of is basically two numbers. Basically it will be a 2D DP. So we'll have dpij. What it will show is it will show basically maximum absolute difference in score of P1 and P2. Okay, so it is going to store this. All right. Okay, so how the transitions will work? Okay, so if you okay, so if we look at a particular state, in this example itself, like 10, 80, 90, 30, let's say we are going to calculate 1 to 4. Okay, we want to calculate 1 to 4. So if we take the first number, that is 10, so we'll be adding a 10 to x's score, and then we'll try to calculate 2 to 4, right? And similarly if we take 30, so we'll add 30 to the score and try to calculate dp 1 to 3. So in both the cases, this will be the other person's score, since we already made a move. Okay, so this is y score, this is our current score, x score. Okay, and so what we wanted to do was we wanted to do maximize x minus y, right? So we'll do nothing but whatever so whatever Okay, so we have this, right? And if we choose the first element, if we choose the ith element, okay, so we'll be adding that to the uh, we'll be adding that to our um, x access score, right? And then we'll subtract subtract the other player's score. Okay, this is y score, and similarly if we take the jth if we take the jth element, and then we'll subtract the other player's score, and out of this we would like to get the maximum, and that is our transition. What is the base case? Am I muted? No. Okay, so base case is nothing but if you have your I and j as equal, okay, in that case your dp ij will be that value only, okay, and at the end the answer will be in dp 1 to n plus sum of the array divided by 2. Okay, so this is the solution. Let's implement it and call it a day. We have a 2D DP, so we had what? The input is n only, n a. So we'll remove this. Okay, we don't need this, and we don't need this. We don't need this. We don't also need this. Okay, so we need this. Okay, and we will have I think I have it. VBLL DP, and DP will be from n plus 1 to n plus 1, or initialized with 0, and then we'll run the loop from int I is equal to 1, I less than equal to n, I plus plus, okay, I plus plus, and for int j LLJ is equal to n, j greater than equal to I, okay, it should be this. Okay, If we had a recursive solution, then in recursion I would go from 1 to n, but in for loop it will be opposite, and I will go from n to 0, and similarly j will go from in recursion from n to 0, and here it will go from I to n. Okay, and j plus plus. Here we'll do one thing, that dp of ij is maximum of dp of two thing actually. If I is double equal to j, in that case dpij is shit. I don't want to go here. Okay, I minus 1. Else we'll do ai minus 1 minus dp I plus 1 j, or a j minus 1 minus dp I j minus 1. Should be good. Exodus ये तो सही है. कुछ तो प्रॉब्लम है इधर में, इसमें ही. काम करते हैं, dp अपन n स्टेट का ही रखते हैं, और अपन i लेके जाएंगे n-1 से यहाँ तक, और ये भी जाएगा n तक. और इस केस में हम लोग इसमें वो होगा पक्का. Okay, we are right. Okay, we need to print this only. Okay. Correct. Should be 10 only. Correct. Should be 49995. And it should be 2. And we'll copy this, paste it, verify and submit it. Wrong answer, TLE, MLE, anything. Wrong answer, TLE, MLE. It worked, and I think that's enough for today. We did what? Stone's question? No, we did not do it, right? Did we do it? Okay, yeah, we did it. Candies. Number of ways to share candies between children. We have slimes. Okay. Combining things. We'll do that sushi problem tomorrow first, and then see what else. And yeah, so this is it for today, and I hope you have a great weekend, and yeah, peace.